So I'm not an expert in anything I'm going to share today. These are just some recent discoveries that I think are fun and fairly accessible. And I will recommend all of them to you, maybe in order. So the first thing is Kabelsalat, or it's just German for cable mess or cable salad. It's the same primary developer behind this as Strudel, which I showed off last time. That's just the JavaScript version of title cycles. But the paradigm is a little different. As you can see, it's for live coding modular synthesis. There's a few inspirations behind it. The main thing that came to my mind was Super Collider. I don't know if any of you have played with Super Collider directly. Yeah. So there's like some similar syntax things, but I think it's a little more accessible. It's just a website, so anybody could play around with it if you want. And I think this tutorial, which we can go through, is fairly easy to understand, but we can start from the editor. So this is what happens when you look it up. Table.salat.dev, and the most basic thing you can do is just do a sine wave and hit Control-Enter to evaluate it. One nice thing about CableSalad is it'll give you a graph of what's going on with your code that's generated at each evaluation. So if I put 500 here, you can see that, let's see, let's go to this.
Yeah, it's probably turned down.
Oh, on the mixing board?
The PA is probably turned off because I was disconnected that.
Yeah. One of these. That's a little loud.
Sign 100, please.
Sign 100. Okay, that's a good number. Much nicer. Okay.
Thank you. Also, just heads up, it is mono, so it won't be left channel.
Gotcha. Yeah, no worries. We have some multi-channel things we can talk about, but we'll still hear both, right? So.
Is that what the two outputs are? Is it the stereo?
Yeah. So by default, it'll give you stereo outputs. One thing that's similar to Super Collider is that there's the same kind of syntax for multi-channel expansion. So let's say you want to do a chord of 100 and 200. You just express it as an array and pass that into the same place you would your argument for the frequency of your sine wave. So we get a little bit of a chord. Is that super audible?
It's like, yeah, it's going to the left and right channel.
Yeah, so in order to hear both, I think we need to mix it down if we're not hearing the right channel. Yeah, there we go. So mix will just take all the signals into a single output or even two, but we can't hear the other one. So just mix it down to one, and these could be however many. Okay, that's multi-channel expansion. One other thing is that if you have another function that's being applied to this, hello. So let's say, okay, disregarding the multi-channel expansion part, if we want to do some amplitude modulation, let's say we want to multiply the amplitude of our sine by another sine. This is a common synth thing. So to do like a low rate sine wave, just put a 1 there. That'll oscillate between -1 and 1, but we could set the range of that to be, let's say, 100, 200. No, wait, this is our amplitude. So we're going to do 0.5 and 0.9, where 1 is your max. So have a little oscillation there. This is a little more audible, right? And if we wanted our expanded thing, that same low-pass filter is being applied to both channels, right? It's being, let's see, where is it represented? Right here in the middle of the graph. But you can multi-expand this as well, and it's going to be mapped onto the same index, right? So let's say we have a sine going at 1 cycle a second, and then another one at 2. And so the one at 2 is going to affect the sine wave that's at the 200 frequency. Right? And so that'll apply, whatever function you apply to.
So is that 2 sine waves being amplitude modulating that?
Mm-hmm.
Oh, I see.
Yeah. Cool. So we did some basic amplitude modulation. We could also do frequency modulation by passing another sine to the front of the sine. Again, not an expert, so let's say we have one going at 3 cycles a second, maybe make it 30. And here's where we're going to set the range of this guy. So we'll remove this. And same numbers. So this is modulating the frequency of that sine wave rather than the amplitude. This could be whatever number. Okay, other thing we could talk about is sequencing. So in order to sequence things, you need like some sort of trigger, and in order to, the way we do triggers in Cable Salad is with impulse. So this will send impulses or triggers 4 times a second, and we can send that to a sequence. So what do we want to sequence? Maybe this first sign here. So paste that in there. We'll pass that value or those triggers to the sequence method. And sequence will also expect an array, if I remember the syntax correctly. So we can start with 3, and then maybe 4, and then 13 or something. Actually, that might be multi-channel expanding. It's kind of hard to hear at this point. So if we made these numbers higher, I think we'd have a better chance of hearing it. Yeah. So 4 times a second, it's just cycling through those 3 values. Is that audible to everyone?
Yeah.
Okay.
So that it's cycling between those values being fed into the sine wave that's modulating the second sine wave?
Yes.
Okay.
Yeah. So it's you can see how Cable Salad is an appropriate name,
Yeah.
since this can get a little bit unwieldy.
Well, you were saying it's like emulating a modular
Yeah.
the syntax looks very similar to Hydra.
Yeah, exactly. So definitely inspired by that sort of thing. What else would be cool to talk about? I mean, there's a low pass filter in here. So we could low pass filter. Maybe give it a little more juice. Not super audible. Might be using that wrong. But there is a low pass filter function. Another thing is feedback. So if you wanted to do like a delay on this, you can pass in a lambda function so add basically adds some signal to your node, right? So we have this like synth happening, right? And adding to it just like adds an additional thing. So you could put another sine wave in here, for instance. So if I did sine 500, that's all add does. It's just like adding another thing.
And where's that on the graph?
So down here,
Oh, okay.
yeah. We picked the bad number. So that's all sine. That's all add does. But you can pass in a lambda function to add as well, and that lambda function will take in as its argument the node that you're adding to. So this is how you would do feedback. And so the basic use case for this kind of feedback is just delay. So if we want to delay it by 0.1 seconds, we need to make sure we don't have too much feedback, so we're going to dial it back using the multiply function. Maybe at 0.8. Kind of hard to hear because the sine is like a constant thing. So we're gonna make this an impulse instead. That is inaudible.
And what's the perk function? Is that
The perk is just like a filter envelope on the, it like creates a gate for those impulse triggers.
Okay, so is that like setting the level where it actuates or something?
Yeah. So like for the 4 impulses, yeah, I think it just sets the level that'll hit, and on top of that, you can put an ADSR filter envelope. A little too short of an attack. Okay, we'll leave that off. Yeah.
On the ground, some of the edges are like automatically labeled and others aren't. What's
Yeah.
that about?
I think, let's see. So the in is going to be generally your first argument. So if we go to our docs, all of the functions will have, or most of them will have this in argument, which is usually just corresponds to whatever is before the dot whenever you're calling the function. So it's that first, the first argument. As far as syntax goes, like something dot something, so sine dot out, this is equivalent to passing in that as your first argument. Yeah. Sorry?
I was going to ask about that, because the whole documentation thing is...
Yeah. Yeah. So depending on what you're used to, this might be better, although you'll end up having a lot of nested parentheses with the really complicated.
Variable.
Yeah, totally. Yeah, you can definitely do variables. This is just JavaScript, by the way. So any JavaScript stuff you can do, including, you know, setting functions and stuff. But yeah, that's the basics. I'll leave it there. I'll say the learn. If you click the learn button, this tutorial is pretty good. It's not as detailed as Strudel is, since this is a more experimental thing versus Strudel. So a little less stable, but down there at the bottom, you'll find features for modules. It's how you can take, like, let's say you built up something really, really complicated and your graph looks crazy. You could just use the module function to assign all that stuff to its own function, which can be used later. But yeah, that's Cable Salad. And I found Cable Salad through the next thing I'm going to talk about, which is Pasta Gang. So Pasta Gang is it's just a group online of a bunch of clowns. Yeah, I think it became Pasta Gang because one of the people involved in it, in the course of the event happening, was making pasta in the background, and someone just came up with the name and it stuck. So now it's called Pasta Gang. But basically the idea is it's a radically open grouping or assemblage of creative coders that kind of like abandons the idea of authorship. So the people responsible for making the Pasta Gang tools, including Noodle, is just Pasta Gang itself. The people who make the videos and the podcasts associated with it and the papers are all just attributed to the grouping, even though, you know, the main people who are involved are named and known. One of the big people who is involved is Toad Pond. Has anyone seen Toad Pond before?
Toad Pond?
I think it's probably maybe a reference to that, but Toad Pond is one of my favorite developers now. Highly recommended. They do great and creative things with very, very meta sort of shit. But anyway, they're involved, and Fruce, the person who does Strudel and Cable Salad, is also involved. But the main thing that they do is jam in this place called Noodle, which is based on Flock. And Flock is a way to get people who are doing live coding together to jam together on the internet in like a shared room. So, you know, at your typical algo rave, you'll have like a projector, two projectors or something. One person's doing Hydra, another person's doing tidal cycles, for example. This is a way you can just like kind of do that over the internet with strangers internationally. Flock is one of those tools. Estuary is another tool that's pretty long-standing. But if you've tried out one of these things before, you may have not been sure how to find people to do it with, or scared to, you know, put your name out there or something. There are communities for that and regular occurrences, but the cool thing is that the Noodle room is always open. And if we try it right now, I'm not sure what we'll see, but I'm kind of excited. But the languages it supports are Hydra, Strudel, Cable Salad, a few other things, but you can also fuck with CSS. So I was talking to Chris earlier about how people will live code the CSS of the page, and you can make it audio reactive. So the size of the text will be bouncing sometimes, which makes it unusable. But we can see what they're up to right now and perhaps join them. Okay. So this is happening in real time somewhere. Let's see. AnyFlux is playing. Human Machine is playing. And I could be in here too. There's no Hydra happening. Yeah, sorry. But yeah, I've been having fun with strangers over this. I don't know why the Hydra is behind. It's not normally like that. I think someone fucked with the CSS. Yeah, sometimes this thing is in a strange state. I found it one time where all the E's were replaced with like an image of the letter E, and there's a common function in Strudel called transpose, and trans was replaced with the trans flag, and other things like this. But yeah, it's very fun. It's a cool community. Highly recommend Pasta Game and their activities. Okay, other thing I wanted to show off was something I just discovered how to do in title cycles, which is Markov chains. Kingdom, who's a pretty prolific title cyclist, used to put out tutorials back in the day, but it's been a few years since he has. A few months ago, he put out one on Markov packed. So this is a function that's been there for a while, I believe, but is just undocumented. So if you go to the title docs and look up Markov, I think, oh, it's in there now. Okay, it's finally added. Well, this is like recently in there then. But I just discovered it. I don't know. There's always more things to discover about title cycles, I feel like. Okay, are people familiar with Markov chains in general, more or less? I can give a basic breakdown. Basically, if you have a graph, which just has like some states in it, right? In this case, it's weather states, and these little numbers here represent like probabilities that one state will transform into another one. So there's like a 0.3 or a 30% chance that when it's rainy, it'll become cloudy in the next state. 50% chance it'll stay rainy, and 20% chance it'll become sunny. And then that's all it is basically. So you can get this graph out of it. In title cycles, okay, that's open, good. You can do this with notes. So let's say we want to play with these sounds. Okay. Yeah, I can zoom in a second. Let's see. Oops. Get these out of the way. Is that good? Okay, cool. So let's say we're playing with these symbols. Okay. Oh, you didn't need the S. I didn't know you could do that. Okay. Anyway, so let's say we're working with these samples, right? And then a Markov hat will expect a certain syntax. So let's say we wanted to use this Markov chain and idea to select samples. Let's see if I can remember the syntax. Just found this the other day. So the first thing it'll expect is a number of events per cycle. So let's say we want to play 16 notes, so 16 events per cycle. We need an initial state, so we'll just make that 0. And then we need an array, which will be a list of states and a list of probabilities. So the basic example, let's say we just have 2 states, so we're just playing with bass drum and a hi-hat. Now what Markov hat generates is just like a list of numbers. But we'll get to that anyway. Let's say our first state is, the way you define this state is just its list of probabilities, and it's an array, right? So let's say it has a 50% chance of remaining in the first state and a 50% chance of going to the next state, and same for our second state. So for Markov hat has this array of arrays. First item in that big array is one state, and this is another one. So this is like as basic as you can make it. Now, it doesn't do anything because, well, we did this. Cool. Okay, so we're just generating a series of 1s and 0s. And this first part is just like the section of the proportion of the cycle that this event is going to take up. But you don't need to look at those numbers. Just look at the very right here. So we're starting with 0, and then basically it's just 50% chance it becomes a 1, and vice versa. Okay, but now we want to use this to make sound. So the way you do that is kind of annoying, but we can take a look at the documentation to help us out now that it's in there. So we'll use fmap to do so. Let's move this down, and fmap is our Haskell way of mapping one set of values to another set. So if we're going to use this chain of 1s and 0s to select an index into this array, which will have our bass drum and our hi-hat. So 0 is going to correspond to the first item, our bass drum, and 1 is going to correspond to our hi-hat. We need these 2 exclamation points, which I think is some Haskell bullshit. This should work. So this is like something you could do much more easily with another function called choose in title, but it's just like randomly switching between our bass drum and our hi-hat. But you can set the probabilities to be more interesting. So let's say there's a very low chance that you'll get 2 bass drums in a row. 16 is kind of fast, so you can still kind of hear that, but yeah, so now there's a 0% chance we'll get 2 bass drums in a row. So you can like manipulate this in real time, which is a lot of fun. If you want to add a third state, say a snare drum, you're going to have to add another set, right, and another set of likelihoods. So 50% chance it'll go to state 1. So these indices are like, this is for the third state. There's a 0.5% chance it'll, not 0.5% chance, but let's say 50% chance it'll move to state 1, so that bass drum. So once a snare drum hits, it's that likely it'll be a bass drum in the next note. A 0% chance it'll go to state 2, and very likely that it'll remain a snare drum. Now 0.5 and 0.9, does that add up to 1? No, right? These all get normalized, so that doesn't matter. One other thing we need is that all of these need likelihoods for each of those states now. So let's say, I don't know, just put in whatever. And we're getting a lot of snare drums on that hit. But right now it's just like a wall of sound. This is the basics of Markov Pat. So one thing that Kingdom recommends is using masking to like turn things off every now and again. So the mask function, just like the 1 is like let stuff through, it's like you're on, and 0 is you're off. So in the first half of the cycle, we're going to let stuff pass through, and in the second half, nothing is going to happen. Right? But this could be, whatever pattern you want. So I don't know. But yeah, that's Markov patterns. It puts with these numbers. So you could say it's very likely for a bass drum to move to a snare drum, which is very likely to move to a hi-hat, and from that hi-hat you could go, or from that snare drum you could go back down to a bass drum. So oftentimes you'll get like a bass drum, hi-hat, snare drum in a row, right? So you get like this kind of repetition, but it's still a little bit random. And it's always like evolving. But yeah.
So the Markov patterns, are those changing over time, or is that like a set pattern that, because they're past 16, so that just give you 16?
Yeah, so if you evaluate like this by itself, right, it'll, it just gave us this list, right, but every cycle that's getting reevaluated.
Okay.
Yeah, so it's constantly.
Oh, so it's like regenerating the random, okay. I see.
Yeah, so it's like moving along the nodes in that graph, just constantly.
Okay.
Yeah. But I've been having a lot of fun with that, and you can use it with any other title function. I don't know, I could share it for the performance later, or I think I might do that from scratch. So I don't know. I made it sound like this. I don't know, you can make it sound cool. So yeah, those are the 3 things that I was going to share.
Exciting.
All right. I've been using live coding stuff lately, mostly for playing French horn, which I'll show after this. But went to PyCon this year, and there was a really good talk about this Spotify library. Let me see. I don't import it there. I don't remember how any of this is set up. It's been a while since I've looked at it. Moment. Pedalboard is the name of the Python library. It's used by Spotify for basically enriching their data sets for audio stuff, for doing categorization and stuff like that. So you can programmatically add effects and all kinds of other things to, I want to say samples, but really everything's just an array of, and I'm going to say samples again, I mean like the 4,100 hertz like sample rate. So it's just a bunch of numbers of like speaker positions. And you can then just do a bunch of audio manipulation at the math level there. But it also has a bunch of nice tools for being able to add effects and mix things together and stuff like that. So I've always liked this idea of being able to do like list comprehension-y kind of things that you can do in Python very easily, but you know, I want to do that in like a live coding environment. I've always felt like Tidal had a nice concision to it of like you can do a lot without changing a whole lot, whereas Ruby is kind of a disaster. Sonic Pi, I keep using it. But basically, let me see. The idea here is that I want to use this tool that I'm making as like a library that you can import into a Python REPL. So, you know, read, execute, or whatever that all stands for. Basically doing the live coding like line by line in Python. And here's a test example that I have here. The idea is I've got this samples directory right here. That's the sample root, and then there's my list of sample files. I'm making a pattern here. Here I'm loading the samples by passing in the root plus the file name and iterating through all the files there, and then creating a pattern using the Python random. That's what I wanted to do. Using the Python random choice, it's like choose. It's selecting something out of this list of samples 16 times, creating this 16-note pattern, and then I just pass it into play pattern. Still trying to figure out like what interface exactly I want as far as all this goes, but yeah, you pass it a pattern, tell it how long to take to play that pattern, and kind of like Tidal cycles, it'll just kind of keep going through that. Ended up with some weird issues with like timing and everything because, you know, none of this is trying to do precise timing and all that. But here, let me try running that. Well, I'm running main.py, so that would be, yes, that makes sense. It's going into that test load samples. So it's going to be running this, loading all of the dirt samples, creating a pattern of those, and then playing that pattern. But I don't see it, or hear it, I mean. Oh. What? Yeah, so it went through, loaded all the dirt samples, or at least I've downloaded the dirt samples, gave it that directory, and was like, hey, load these. And there's actually a bit of a lag when it goes to load all of it. Then it creates a pattern of 16 random ones. So, and you can actually see here. It feels like it's staying in time, like it's not noticeable the drift it's doing, but I have it printing out every time it goes through like how much time it lost from like trying to play the samples and staying in time. So it's losing a couple milliseconds every loop. So I think I might have to try doing like some kind of scheduling stuff to like make it real time or whatever, but the idea would basically be that you could just keep running this kind of stuff. Actually, let me Let me try doing this in REPL. Let me see. Okay. So I guess if I'm in Python here, I'm kind of guessing PyLoops. Can I just import all this? Yeah, so here's the Python REPL, import random, and that would be from pyloops.sample, that's the, current working name. And then, so here, that's how you would, unexpected indent, oh. And yeah, that took a little bit. This will make a pattern. It'll yellow first because of the indentation. And if I print out the pattern, you can see like there's, actually, let me, yeah. So there you can see it's just a bunch of these objects. So if I do pattern indexed by 0, it's that, and will that do it? Oh well. I can't remember what any of this is. The samples, they've got all these attributes about them. But again, at the lowest level, these are basically just lists of samples that you can, they're NumPy arrays really. So you can do any kind of manipulation you could do on NumPy arrays. I've also been messing around a bit with like, trying to not make this overly complicated, but doing sort of like a mixing board type of thing, similar kind of graph deal as the stuff you were demoing, May, where it's like you can make like a whole array of inputs and like feed them into each other and mix between them and all that stuff. But yeah, let me do that one more time and then I will move on to some of the other stuff I've been doing. So if I then say play pattern, the pattern, and then t equals 2, it should play a similar thing. But that's blocking. Okay, and then I can stop it like that. I could make this faster. Yeah, no, that's really all there is to this so far. But yeah, no, the idea was I want to be able to do cool Python list things and all this. Hey, Chris Hatch.
What up?
So,
The list is samples or just like a 44?
oh, so yeah, I mean, in that case, so the thing that I had here assigned to pattern, that was a list of these sample objects that I have. So I made like a class for containing the samples, overused term, but sample in the term of like, oh, go to this file and load it into memory. That's a sample that I can trigger. But in there, you can, like, here it's got the path of where that is. Let me see, self.data. Yeah, so data and SR is sample rate, but data is like the audio as type numpy float 32. So that's just a numpy array that's in there. And helper function for load directory and all that. But yeah, I have not really messed with this in over a month. I should. All right, yeah, that's a cool Python project that I've been working on that that'll be fun to have at some point. The main thing I've been using SonicPy for, like on a nearly daily basis, has been French monographs. you warm up every day, so you don't have to warm up every day. So there's this, lipsmouthpiecehorn.pdf, there it is. So there's this warm-up, it's the Carmine Caruso method. He's some saxophone player from the past that taught a bunch of brass people how to like play their instruments better. And Julie Landsman, who's a horn teacher at the Juilliard, has really like taken his stuff and is like preaching the word and all that. So there's this, the second warm-up in the series called Lips, Mouth, Piece, Horn, where basically the first time you go through, you buzz just on your lips these notes, like starting on a concert C, horn G, bending down to a half step below and then coming back up. I'm not going to do that, but the second part is you play them on a mouthpiece. And I use a brass tube to like add some resistance and all that stuff to it. But not having reference pitches for all of this makes it tough if you don't have perfect pitch. I don't. So I made this tool where it is a Sonic Pi like series of live loops where I've got the different exercises here. Because again, to look at this, there is exercise A, B, and C. And basically what I do is I just change this variable at the top of which exercise I'm working on, what the BPM is, setting all these defaults, and the -7 here is to transpose for French horn being an F. But I basically say like, here's the note to start on, here's the note to end on, and it basically goes through like, okay, start on G, go down, all that stuff. And I've also got a metronome. So this is a metronome loop down here at the bottom that is cueing this click cue that everything on here is like listening for. So these are all syncing to the click, sleeping for, and doing all the appropriate things here. So I will demonstrate that shortly. Something's not right. I think Sonic Pi probably needs closed. I'll get the next thing right. Goes. Okay. And I should double check the audio settings. Output, yeah. And input, all right. But yeah. Basically, it's nice to have this note that you can hear and see, like try and get right in the middle of like being tuned and all that. Other than that, the other cool thing that to do with Sonic Pi is that you can use it similar to the Python Spotify library I was showing. Where it's got a bunch of tools for being able to take audio inputs and apply effects to them in Sonic Pi, and I'm assuming tidal cycles, but I don't know. You can take you use this with effects record to record basically a mic input. Well, no, sorry. This record is doing something differently here. I'm going to actually stop these. just so yeah, that stopped. So what I'm doing here is I've got this loop that's going around, and it's recording onto a series of buffers. Here I have it set to 16 buffers, each of a duration of 8 seconds. This here is a ring of buffers, and that is a concise way to create them in Ruby. But basically I've got this effects chain where I've got reverb and a really long echo going on the outer loop of everything. And here I've got this live loop that's going around and recording onto the next buffer by doing a tick on the, what is that called? Ring. So a ring is like a list, but when you go to the end of the list, it goes back to the beginning. And buffers.tick, that is ring.tick, is just grabbing the next thing from that list. I've got a little output or a logging thing here saying it's recording onto whatever buffer. And here, yeah, it's this with effects record. That's the thing that is saying record whatever happens inside this block of code onto this buffer. Here I've got my live audio coming from Mike, and it sleeps for whatever that duration is. So here, let me see what this sounds like. Oh, I gotta turn on the silent brass mute. This is a mute that has a microphone somewhere in it that, oh, hey, there we go. We'll take that and play it through there. Let me actually play with that. So part of the idea here was like I was trying to play this into my delay pedal and basically do that where I could be playing something and then counterpoint, playing alongside it and all of that. But none of the delays that I could get out of my pedals were fat or long enough where I'm like, this is like BPM is 85 here, and the, what is it? This echo, the phase is 8, I guess not 8 seconds, but 8 beats of 85 beats per minute. Another thing you can do here would be, you can add any kind of effect on top of it. So let's add a bit crusher. Wait, what? Oh, I see. Let's see what other effects there are. Ring mod. I bet that'll be cool. I saw a video the other day of someone playing Walk by Pantera on French horn, and that was interesting. That doesn't sound weird. Do I have to stop it? that sounds like a ring modulator. But yeah, let me see, with this second part. So the thing that is going on here, this is basically the same code that I used before for the singing bowl. So it's taking this, or it's taking those buffers that it's recording into, and then it's randomly choosing one of those buffers, adjusting the rate to one of these values. If I want to stay in the same key, I can change it to that. I guess I select all of this. Where here it's either going to lower it by an octave, wait a second. No, it's going to either play it backwards at the same speed, play it backwards an octave lower, play it forward an octave lower, or play it forward at regular speed. And actually, yeah, that. So now if I stop that first loop, it'll stop overwriting all of the, I don't know, little buffers, and it'll just keep what it currently has in memory and just be randomly choosing from that. But yeah, that's really all I had to talk about. Thank you. All right, so should we do some performances of sort, and then I think we can wrap this all up and then head on over to Bantha. Was it 7:30 now? So, yeah.
Is it doors 7:30?
Doors are at 7. The show starts at 7:30. Do you want to do visuals or audio first?
Let's do visuals first.
Okay.
Sure.
Oh, second projector?
Or do we want to do both of them?
We
both
can-
of them.
Yeah, we can project both of them. Do you have an HDMI adapter of sorts?
Oh, well, I can accept those, I think.
Yeah, but I only have one of these.
Yeah, shoot.
Oh,
I don't
no
think I
problem.
do.
Yeah. Here, I'll take this. This isn't doing anything.
Great.
Oh, so I brought, so this is actually a old, I think the date on it is either 1947 or 1953, but this is how they used to make French horns. This is actually trompe de chasse, like the hunting horns. There's no valves compared to this. And this one was actually made in France, but you only get the notes of the harmonic series of this. So you only get whatever notes are going to be there, and then you can use your hand to lower them. But yeah, I don't know, another toy I brought.
I didn't have a problem with the
Yeah, well, I think this is technically a hunted horn, because it's not like it's not a natural horn like they would play in other times, because there's no tuning slides. You tune it by moving this further out,
Yeah.
and it's a disaster. Yeah, what was it? The horn used to be an outside instrument, and then they brought it inside.
I was about to say something like Lord of the Rings.
Is anyone here strobe sensitive? Okay. Might get strobe.
you. And now I guess we don't have to move, or I can just take
Oh,
that from
yeah.
here. Yeah. Here, you take this USB-C cable.
Perfect.
I'll take this one.
This is my favorite one.
Oh no. Yeah, what is it with like, I've had bad luck with getting Hydra to run locally.
Oh, yeah, I connected to Wi-Fi
Mhm.
for sure. But it'd be fun to like use like local video.
Oh, yeah.
That looks right. That looks right. Okay. Testing. Okay. Still works. Should I start from scratch or?
You start wherever you want. I definitely didn't start from scratch.
Okay. Okay.
I'm certainly not going to start from scratch this time.
Well, you got some prepared Hydra?
I mean, I've got a bunch of sketches here.
Okay.
Let's see. That looks good. So, waiting for volume control.